This is the tutorial for Chapter 12, Section 7, titled Theoretical and Experimental Probability. And let's take a look at both types. Let's take a look at, first of all, probability. The probability of an event, and this is the notation that you use, capital P, and then you write what the event is. So if it's like rolling a die, you'd write that, or spinning a spinner, you'd write that. And it tells you how likely an event will occur. So probability is between these two numbers. It has a range from 0 to 1, where 0 means it's impossible. Like, for instance, if today is Monday, me saying that, well, tomorrow is going to end up being Saturday would be an impossible event, because we have to get through the other days first. A certain event means 1. So we say if something is definitely going to happen, like the sun will rise tomorrow, then we have a certain event, which would end up being 1. 50% is equally likely to occur or not occur. Anything less than 50% is less likely, more than 50% is more likely. And so that's where our range should be. So if you get a probability of over 1, then you did something wrong, because it needs to be between these two numbers. So let's take a look at our first problem here. It says that, first of all, let's take a look at theoretical probability and what that is. It's just the number of favorable outcomes over the number of possible outcomes. So favorable outcomes means ones that will occur or could occur in this situation. So here we have a spinner, and in that spinner we have 15 equally sized sections. So equally sized means one section is not going to happen over another. All of them have an equal chance of being, for the spinner, the arrow to end up on that section. And so these sections are numbered 1 through 15. We're supposed to find the theoretical probability of landing on a given section. So here's the event. We want to land on 15, which means the slice that is numbered 15. Well, there's only going to be one 15 out of 15 numbers, or 15 sections, and so that would be our probability. The number of favorable outcomes, well, to get a 15, there's only one way to get a 15, so that's why it's 1 over the total number of outcomes, which is 15. Well, an odd number, if you look at the numbers, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we've got 11, 12, 13, 14, and 15. So if you look at just the odd ones, we have 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 odd numbers out of 15 altogether, and so that would be the probability of getting an odd number. Well, even numbers, well, there's 7 left over that are not odd, and so the probability of an even number would be 7 out of 15. Probability of not a 5. So the probability of getting a 5 is 1. So basically, when we see the word not, we're basically taking a probability of a certain event and we're subtracting the probability of getting this event, which is 1 out of 15. So to not get a 5 would be to get any of these other values, 1 through 4 or 6 through 15. So everything but 5. And so if I take away 1/15 from 1, that leaves me with 14/15ths. And that would be our answer. Probability of less than 5, well, less than 5 does not include 5, so it would be these first 4. And so it would be 4 out of 15. Greater than 8. So greater than 8 does not include 8, so it's all these other numbers starting at 9, 10, 11, 12, 13, 14, 15. So there's 5, 6, and 7, so it's going to be 7 out of 15. So a multiple of 5. So we have 5, 10, and 15 makes 3. So 3 out of 15, and then just reduce the fraction. So that makes 1/5. So less than 16. Well, every number is less than 16. So if that's the case, since every possible outcome is less than 16, that means that we have a certain event. That means the probability is 1. It will happen. Probability of a prime number. So the prime numbers we have are 2, and then 3, 4, 5, 7, and we've got 11, 13. Those are our prime numbers. So we've got 1. 1 is not a prime number there. 2, 3, 4, 5, 6, 7. So we have 7 out of 15. And those are different values here, and let's take a look at the next type, and that one says it's asking about experimental probability. So the difference between theoretical probability is theoretical probability we did not actually do or spin the spinner. We were just going for what happens if it lands on a 15. So we were theorizing what would end up happening, about 1 out of 15 chances that would happen. Well, here it's the probability of the number of times the event occurs. So we're actually doing some trials. And so how many times it actually occurred over the number of times this experiment was done. And so since we're using experimental probability to make a prediction, predictions are not exact, and so we would best want to round our answers in this case. So if you end up getting, like, let's say it was maybe 1,013, maybe you'd round it to the nearest tens or hundreds, whatever they end up telling us. If you have decimals, definitely round them to the ones place. So in this situation, it says 120 randomly selected students. So that means all of these numbers here are going to end up adding up to 120, and they do. And so when we go ahead and read on, it says that these students were asked to find or to name their favorite sport, and here are the results. And so this is experimental probability because we actually have true numbers from an experiment from this randomly selected group, and we're supposed to find out what the probability of selecting a person who favored basketball. So we looked to see how many people favored basketball, and that was 30 students out of 120, and then we just reduce. So the zeros cancel out, 3 goes into 12 1/4 of the time, so 1/4 would be our probability. Probability that the person would like soccer was 20, but we do it over the total number, which is 120, which would reduce down to 1/6. Baseball was 22 over 120, so we divide by 2, and we're getting 11 over 60. And the last one here, football, and that one is 34 over 120, which reduces down to 17 over 60. So those are the types of problems that we're going to end up seeing on tonight's assignment. Good luck.